Okay, so we're now on the powers unit. I looked over this unit and I thought, all right, what am I going to do a tutorial on for this unit where it's kind of tough because we don't have any one big idea. We've got a lot of small ideas all through the unit. So I figured I'll pick out a few and talk about them specifically. So first off, what is a power? Well, we call this whole thing a power. So if you pick a number that we call the base with an exponent up top, the whole thing is a power. So here 2 would be the base, the 2 up top here is the exponent. Here 2 is the base, the 4 up top is the exponent. Again, remember that the number up top tells you how many times you multiply the base by. So here, this would be 2 times 2 times 2 times 2 in this case. Now, we went on further to that. We talked about powers of 10. We talked about multiplying and dividing exponents, and that's what I'm going to talk about here, and then I'm going to look at how to do that with order of operations. Okay. So, one of our power rules was that if you multiply 2 powers together, you add exponents. So in this example, as long as they have the same base, if you multiply 2 to the 2 times 2 to the 4, we can actually add up the exponents. So here the exponent's going to be 2 to the power 2 plus 4, or 2 to the power 6. Okay? That's one of our important power rules, and that's the multiplication power rule. All right, next I want to look at the division rule for powers. And what we said there was, if you have one power divided by another power, as long as they have the same base, this power divided by this power is simply this exponent minus this exponent for the power of your solution. So what I mean is my answer here is going to be 10 to the power 4 minus 2, or 10 to the power 2. So if you're dividing 2 powers, you can subtract exponents. Okay, that's the second power rule. So what we're going to do next is we're going to put everything together. This single example has a large number of things we've talked about throughout the unit. So first off, each one of these is a power. So this is a power, this is a power, this is a power, this is a power. They all have bases and exponents. Base of negative 12, exponent of 2. Base of negative 2, exponent of 4. Another thing in this problem is we have a power of 0. Remember that anything to the power of 0 is 1. There's another thing in there. We've got our multiplying power rule in here. So there's a lot of different things that work in this problem. So remember when you've got one of these order of operation type problems, to do your work slowly line by line. Don't try and simplify too much at once. And the other thing is, remember your order of operations. We want to start with brackets and exponents, then do our multiplying and dividing, then do our adding and subtracting. So I'm going to do my exponents or powers first. So I'm going to do this, 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 and this first. So I'll do the top, then I'll do the bottom. So for the top, negative 12 to the power 2 is 12 times 12, and negative 12 to the power 4 is negative 12 times negative 12 times negative 12 times negative 12. So if you expanded these out to numbers, you would be able to get the right answer, but I'm going to show you a shortcut here, something that you can save time on. Remember, if you've got the same base, we said that if you multiply 2 powers together with the same base, you can add exponents. So a power times a power, as long as they have the same base, you can just add exponents. So to save time, I'm going to make the numerator negative 12 to the power 6. 2 plus 4. Okay. I've also demonstrated now that I know what the multiplication power rule is. In the bottom, on the next step, I'm going to be dealing with these 2 powers. So I've just rewrote it out here. Now I'm going to deal with the bottom. So I'm going to rewrite out the top. So first off, this one, negative 2 to the power 4. That's negative 2 times negative 2 times negative 2 times negative 2. If you have an even number in the exponent, your answer is going to come out as positive. In this case, it's because 4 negative signs cancel out, right? 2 negative signs make a positive, another 2 negative signs make a positive. So this is going to come out to a positive answer. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we've got 2 times 2, 4, 8. 16. So just double check that you're not making an error. You can use your calculator, but don't rely on it. So I've simplified this one to 16. Remember, don't do your subtracting first. You want to take care of your exponents first. 12 to the power 0 is 1. Anything to the power 0 is 1. So now I've got it even more simple. I'm going to now go over to the right. Negative 12 to the power 6 is something you want to do on your calculator. But if you put that in on your calculator, it's going to come out to be a positive number. And it's going to come out to 2,000, or I'm not even going to try and say this until I finish writing it. 2,985,984 on the top, and the bottom, 16 minus 1, 15. So you notice all the way along here I've been doing multiplying, dividing, exponents. My last step, I took care of my subtracting here in the bottom. So I'm almost done. I just need to represent this as a single number. Again, use your calculator. Divide that number up top by 15. And you get 199065.6. So oftentimes you'll see your book talking about putting expressions in standard form. In exponents, standard form looks like this, just a single number. Okay? So we've gone through step by step, we've simplified, and we've actually taken this big expression and made it into a single number.